Greetings, my name is Ng Zun Wen. I'm a third year chemistry student from UMT, and in this video I'll be presenting about the collaborative work between me and my project leader Dr. Fariza and also Greenfinder. The title of our product is Ignis, 21st Century's Green Laser Pointer. By the way, the name Ignis is inspired by the Latin word for bright. Let's start with the problem statement. I'm sure you are familiar with such commercially available green laser pointers. These laser pointers are used for video presentations in the education industry. However, did you know that these green laser pointers also produce dangerous and invisible infrared laser light as well as the green laser light? In such a laser pointer, the green laser light is generated by converting infrared laser light from an infrared pump diode using non-linear crystals. However, since the conversion process is not 100% efficient, some infrared light will be emitted by the laser pointer. Infrared light is a safety hazard as it is invisible. Since it is invisible, it means we will not be aware of it. This becomes an issue when we are exposed to it for long periods of time, as infrared radiation can damage the lens of our eyes, causing health issues such as cataracts. This leads directly into our objectives. There are two objectives in this research, which is to create a green laser pointer with no residual infrared radiation and to create a green laser pointer that has high power. The schematic below is a rough estimation of how the green laser pointer looks like. Here are the individual parts of the Ignis laser. The parts include a laser diode, laser body, copper heat sinks, electronic laser driver board, focusing lens, and a battery. Firstly, I sketched the 3D model of my laser pointer body using a free 3D modeling software called Fusion 360. Then, I sent the 3D CAD files to a CNC shop on Shopee to fabricate it. For the material of the body, I chose aluminum as it has high thermal conductivity and heat capacity. Making the body out of aluminum will help to absorb the waste heat produced by the laser diode. The other laser components were purchased from a seller from Taobao.com. Assembly of the laser was quite easy as I have past experience in making lasers. In this specific YouTube video, I documented the build process of an early prototype to Ignis. The total cost of the laser was around 300 ringgit, but it could be lowered if it undergoes mass production. And ta-da! This is what the laser looks like. Here is a short comparison between the commercially available green laser pointer versus the Ignis laser. Based on this video footage, it is obvious that the Ignis laser is much brighter than the commercially available green laser pointer. Due to the ongoing pandemic, I'm not able to use my university's equipment to perform characterization tests on the Ignis laser. However, I do have a DIY UVV spectrometer at home and I used it to characterize the wavelength of this laser's output. With the DIY spectrometer, I was able to perform qualitative analysis of the laser output, and the wavelength output of this laser was measured to be around 525 nanometer with an accuracy window of 10 nanometers. Since I do not have access to a laser power meter at this moment, I can't quantify the power output of this Ignis laser scientifically, but I can show that Ignis is powerful enough to set paper on fire when focused into a small point. Based on the datasheet of this laser diode, the estimated output power of the Ignis laser should be around 700 milliwatts. Lasers have a wide range of applications, ranging from simple barcode scanners all the way to advanced laser projectors. To further innovate on lasers, me and my project leader Dr. Fariza have been working with Greenfinder Asia to create a LiDAR-based device that uses time of flight concept to measure the weight of a ship. By mounting a LiDAR device on the deck of a ship, and with a little bit of math and computing power, we will be able to accurately measure the weight of a ship based on how high the deck is from the surface of the ocean. If such a device is successfully created, it will surely benefit the ports around Malaysia such as Port Klang. Working in ocean environments will mean that waterproofing is necessary, which is why we have already created a waterproof laser pointer to learn more about waterproofing lasers for operation in maritime environment. The small scale test is showing good results as seen in this video. To protect our idea, we have registered on my IPO for our copyright. Besides that, we also have a letter of intent from Greenfinder solidifying a 2-year collaboration effort. To cap it off, last year we won the silver medal for our project in Pi NVEX 2020. That's it for this video. Thanks for watching.